Come down with me to Argentina. On the way to Argentina, I want to stop in Brazil for just a second. Now, we were just concentrating on this part of the map right here, the Gulf of Mexico. This is northern Brazil. This is the Amazon River. And right here at the mouth of the Amazon River is the mud from the Amazon River. And there's only 4,500 years worth of mud accumulated at the mouth of the Amazon. And you'll notice that there's a flat sand bottom on either side here, right up against the side of the continent. As a matter of fact, these flat sand bottoms are called abyssal plains. Now let's go down to Argentina and let's just see how well do those continents really fit together. Well, come with me to Argentina. You'll notice that Argentina, the coastline of Argentina is a very ragged, jagged coastline, looks like a sawtooth. But you'll also notice that here, off the coast of Argentina, there's a wide continental shelf here. As a matter of fact, it's twice as wide as Florida. It is 200 miles wide. And you notice it has a nice smooth V shape. And up here in Brazil, you notice it goes in, out, in, out. Now, if I were to move these 4 points over to here, you notice it would fit the in, out right here in Africa. And this nice smooth V would fit right here. As a matter of fact, these are the Falkland Islands off of Argentina. Here's this underwater peninsula right here, but you notice it perfectly fits right there. And so you really can see that these two continents here used to fit right there. Is that correct? And another thing, too, if you'll come up here, these are the Grand Banks off of Newfoundland right here. Notice this piece of land right here, this peninsula of land right there that sticks out under the water, but it looks like a knife blade. Is that correct? Now, if you take a look at the shape of the Grand Banks here, you'll notice it perfectly fits that notch right there, north of Spain. And remember, too, that on a round globe, if you make it flat, the top and bottom distorts. But actually, the continental shelf of Greenland perfectly fits the continental shelf of Norway. We really can see that these 3 points here, South America, the Grand Banks, Greenland, all perfectly fit up against Europe and South America. Let's take a look at the little Indian Ocean over here, and let's see if there's some things in the bottom of the Indian Ocean that might be of interest to us. Now, do you notice these little round dots? There's one here, here, there's one there. Do you see those little kind of dots there? Those are actually underwater volcanoes. They're actually pointy and cone shaped. That's why they look like little dots on the map. And here's another feature in the Indian Ocean right here. This is called the 90 East Ridge. It's a huge ridge going basically north and south in the Indian Ocean. But the third thing I want you to take a look at is this right here. This is an underwater mountain range. And let's go out towards the Pacific here. You notice that the underwater mountain range here perfectly fits the shape of how Antarctica was broken off of Australia. On a round globe, it is perfect. You notice this crack continues in across the Pacific here. It comes inland at the Baja in Mexico, comes up the California coast, but there it's called the San Andreas Fault. That fault continues all the way up to Alaska here. Then it goes through the Aleutian Islands here, then through Kamchatka, Japan, the Philippines, out across New Guinea to Samoa. At Samoa, it turns 90 degrees, goes right straight through New Zealand, and meets itself again right here. So let's think. That crack comes out of the Indian Ocean right here, all the way around the Pacific, and meets itself again right there. Now, I'd also like you to take a good look at this crack here. It's actually an underwater mountain range. This mountain range does not have a single row of peaks down the middle like the Andes. It is a parallel set of ridges with a gap down the middle, and the land rises upward on both sides. These are the fountains of the great deep. These are the springs of waters that knife through from below at the beginning of the flood. As I have demonstrated through the use of the three-dimensional globe, the crack that goes around the world and breaks off 3 continents at the beginning of Noah's flood starts here at Caesarea Philippi. Caesarea Philippi is located at the northeast corner of Israel in the Golan Heights. Here, a natural spring forms the pool of Banias. Today, from this point, the crack begins and starts moving south down the Jordan River Valley. It passes through the Sea of Galilee, down through the Dead Sea. Then traveling south, it forms a valley between the Dead Sea and the port city of Eilat. The crack then turns southeast, forming the bottom of the Red Sea. At the southern end of the Red Sea, the crack turns 90 degrees and moves northeast out to the Gulf of Aden into the Indian Ocean. It splits. To the east, it breaks off Antarctica from Australia, goes across the Pacific, comes inland in Mexico, goes through California to Alaska, then through the Aleutian Islands, through Kamchatka, Japan, the Philippines, turns, goes through New Guinea to Samoa. At Samoa, it turns, goes through New Zealand, and meets itself again in the South Pacific. In the Indian Ocean to the west, it travels around South Africa, goes up the bottom of the Atlantic, near the North Pole, and ends near central Russia. Isn't that amazing that a Christian Croatian scientist whose name was Mohor Revisic scientifically proved in 1909 there used to be a layer of water 1 mile deep located right underneath the Earth's crust at the time of the creation. And over 99% of the water that flooded the Earth came from that water coming from below. Now I want you to think about this. As you go into the Earth gets hotter. Initially it gets hotter at 118 degrees Fahrenheit per mile on average as you go down. It changes as you go into the Earth. The Earth in its center is 6,700 degrees Celsius, 13,000 degrees Fahrenheit. It's really hot down there. But think with me, it starts to get hot at 118 degrees Fahrenheit per mile as you start down. So when you go down 4 miles, the temperature of this liquid water is about 500 degrees Fahrenheit. Now, what do you call liquid water at 500 degrees Fahrenheit? Somebody said hot. Well, well, actually, all of you are familiar with this kind of water. How many of you still have in your kitchens or your grandma's kitchen something called a pressure cooker? Pressure cooker, right? Now, how many of you have ever seen a pressure cooker that didn't hold on? Okay. That kitchen was destroyed by 1 to 2 quarts or 1 to 2 liters of this kind of water. Is that correct? Now, the actual technical name for liquid water at 500 degrees Fahrenheit or approximately 250 degrees Celsius is actually called super hot water. That is the technical term. It's called super hot water. We still use it today in electrical power plants and various manufacturing processes, but it's really just liquid steam. Now, liquid steam is like an accident looking for a place to happen. Remember the pressure cooker that didn't hold on? So I want you to think about this. God put that layer of liquid steam, that accident looking for a place to happen, right under the eggshell of the earth at the time of the creation. Remember that in Genesis chapter 1, remember it says this, that when God created the earth, he created the earth with the waters above and the waters below. Is that correct? Now, the waters above, this was a lot of extra moisture in the upper atmosphere that's not there today. There were shallow seas on the surface of the earth. As a matter of fact, I mentioned Pangea. I said it was a teaching done primarily by evolutionists, right? But actually, it's a biblical concept. When God created the earth, he created the earth like a round ball of clay. And on the surface were the waters of creation, Genesis chapter 1, verse 2. Is that correct? Verse 3, God says, actually in Hebrew, light be. Or, let there be light in the English translation. But what is the very next thing God does on the surface of the earth? Doesn't it say that on the surface of the earth, the very next thing God does is he causes the dry land to rise up out of the water. Is that correct? Right? So God causes the dry land to rise up out of the water. And in the Bible it says this, he gathered the water on the surface of the earth into one place. Is that correct? Well, if the water on the surface of the earth is in one place, where's the land? The other one place. Very good. Okay. So the teaching of Pangea is actually a biblical concept. Is that correct? That all the land really did fit together at creation. Now, there were a few islands, but that most of the land fit together in a big supercontinent. We can refer to it as Pangea. So there were shallow seas on the surface of the earth, 1 mile deep, and the land masses pretty much all fit together, except for a few islands sticking through from below. And that's what happened at the creation of the earth. Now, with that in mind,